Nick. Okay,
All
Nick,
right.
it's all yours.
All right. Good morning, everybody. It is a pleasure to meet you. It is extremely weird to not know any names or faces from Lambda, but my name is Nick. I am a Lambda alumni. I was in Web 17 full-time, and then I was in CS 18. I didn't do any TLing, but I was pretty active in Slack until they basically kick out all the alumni. So sorry about that, but I'm glad to see you all here. My background is I've been a support engineer in Silicon Valley for about the last 7 years. I was at GitHub and then Zapier before taking a year off to do Lambda school, and now I work at Heroku as a platform support engineer, which functionally means that I spend about half my day answering email and about half my day trying to make Docker and Python work better on Heroku. If you, by the way, have any problems getting Python projects running on Heroku, please talk to me. There's a lot that we're working on right now.
I
So
literally
feel free to let me know.
I'm working on a DS project
Yeah.
where I'm trying to deploy a Docker app to Heroku, and it freezes on the install. If I don't do it with the Docker container, it still freezes. So
which is it that what's your dependency setup? Not to like derail us, but this is data science in particular on Heroku is a major pain point that we're trying to fix right now. What are your dependencies?
Fast API,
nice.
Transformers, Torch.
Okay.
And I think that's the two major ones. They're smaller dependencies.
When we finish this, if you have time, I would love to talk to you more about that, because those are like you are falling square into the oh no crack for our entire for our entire setup.
It's become like, wow, I can't believe I got to go out and find something else for this.
Right? Yeah. No, I mean, I don't want to say you'll have to, but it might be, because the changes we need to make the kind of workflow that you're doing make sense might not happen fast enough. But anyways, first of all, thank you. I absolutely want to talk to you about that. If anyone else has issues with the build pack or anything like that, I'm in Discord. Please feel free to hit me up. The only other bit of housekeeping I wanted to say is, since some of you are in like the career search phase, in the resources channel, I just dropped a repository called Hiring Without Whiteboards. I have very strong opinions generally, but in particular about hiring in Silicon Valley. I've gone through this a lot. I've been on hiring panels. I think whiteboards are a toxic mess that does nothing but kick extremely qualified, valuable people out of the industry. And I tend to not like rewarding companies that do them, because the companies that need whiteboards, like Google and Amazon, although I even think that's arguable, are not most of the jobs in the industry, even though people like to cosplay as Google and pretend like you need to invert a binary tree to build a custom like React front end. Neither here nor there. We'll save that rant for another day. What I am here to talk to you about today is code challenges. I found Doc again, basically, after leaving Slack at Lambda, and got involved. So you'll see my name a little bit all over our GitHub, and throughout Discord a little bit. And I kind of started poking at code challenges a little bit and building my own. And so what I want to talk about today is what we think we want to do with code challenges, or actually what we're going to do with code challenges, I think is a better way to say that. Why we're doing it that way. How you can help us. And then if we have time after all of that and questions and whatever else, I think maybe we can just do, we can try a giant group pairing on one code challenge so people can see the workflow and we can work through it together. Does that sound good for everybody? Solid. Okay. So the first things first is, we have a code challenges repo. Lambda has a code challenges repo. I think it was just called whiteboarding when I was there, and they used to do pairing. I don't know if they still do that in CS. Oh, that's a bummer. That repo was super fun. Definitely go find it. But one of the things that I think people get stuck on in creating code challenges is they get stuck on these whiteboarding challenges. And whiteboarding challenges are great, and I think data structures and algorithms are extremely important. I think knowing them and having gone through Lambda CS like radically changed how I thought about code. But at the end of the day, you have Exorcism, LeetCode, HackerRank, and probably 5 or 6 other websites that are providing you general purpose data structure and algorithm language agnostic whiteboarding. One, I don't think that that's a good way to compete. I don't think that's like, we're not going to do that as well as HackerRank is. And 2, we're a Python user group, so we get to be a little more selective and a little more choosy. And so that led to some conversations with me and Doc, and then me and Brandon and Josh last night, which was basically like, what if instead we didn't do data structure and algorithm stuff? What if our goal wasn't, let's make you a really great whiteboarding coder, because I think that is a very unique skill. And what if instead we said, hey, let's create a pathway to make you an absolutely incredible Python developer. Let's take you from, okay, I know maybe the basics of Python, and then get you all the way down to pick a standard module, a standard library module, any module, and we will like go to the races and try to give you actually useful programming information in this language, Python. And the answer there was kind of a resounding yes, with some ideas and reservations from Brennan and Josh. But ultimately, if you look at the code challenges repo, you'll notice that everything has been moved. And the reason for that is that we decided that was a good thing. So as of right now, we have a kind of 100 to 500 series pathway to take you from, nothing or very little about Python to we're just going to create some code challenges for as many standard many standard library modules as we can, with the ultimate goal being that you from the bits up learn Python's specific object model, its specific peculiarities, how it handles memory references and variables, random things like generic typing versus specific typing. I'd love to get some async await in there, but with the ultimate goal being that you don't need to pip install anything. We're limited to just the Python standard library, and you'll be doing actual things in order to learn, right? Like the easiest example in the 100 series is a challenge called Circle right now, and that challenge is essentially just, hey, here are some requirements. You're going to build a circle class that behaves this way, and there will be some auto updating parameters. And the goal with that one is just like, let's get used to the basics of like building classes and like functioning objects the Python way. There are some benefits and drawbacks to this. So first benefit, I think these are going to be a little more fun, and I also think they're going to have a better on-ramp than build merge sort, which the good thing about build merge sort is, I said this last night, but merge sort is fun. I just like writing merge sort. Like that's just a fun thing for me. The bad thing about merge sort is it's a catch-22. You like have to know merge sort in order to implement merge sort. And so like most whiteboarding challenges, it isn't so much teaching you something as it is testing whether you already know something. And we're kind of purposely avoiding that. The downside of this new structure is it's harder to build challenges for. And this is where we move into how you can help us. So I'm going to share my screen real quick because that will make things slightly easier. So if you go to the code challenges repo right now, there is a project. This project is called Overhaul Code Challenges. In here, we have headings. So these are the series, and then these are the topics we think every series should cover, that like challenges should touch on. A challenge can be applied to more than one topic. I just wanted to, because I put this list together, I just wanted to make sure that there was at least a list of like, cool, you probably shouldn't talk about tuple unpacking and packing until after like someone has completed this basic stuff, right? Um, the way that you can help is by submitting challenges, and I updated documentation in the README for what a challenge contains, and we'll hopefully be adding like scripts and stuff to generate that process much easier for you. The hard part about building challenges like this is, for a little while, it's going to be one of those things where people submit challenges and they have to like really think through, does this force people to learn things the Python way? And to that end, I'm just going to be pretty involved for probably the first few weeks. So we'll Doc, Brannon, and Josh. And the ultimate goal of every challenge is you're going to learn a set of topics. So if you come down here, like here's the circle challenge I talked about. The topics here are classes, properties, and Dunder methods. You're going to learn a set of topics, and the goal is to make you like have to read good Python code, good Python documentation, and a decent amount of Python resources. Some of it will probably be overly simple. So for example, if we are in the Essentials challenge and you're building something, we need a challenge. First of all, we need a lot of challenges right now, so it will be slow going and under construction. Please submit any ideas that you have. But also some things like variables, values, and types, that's going to be a pretty easy code challenge. If you're assuming that no one knows how to make a variable, then you're going to be writing tests to check whether a variable exists and also whether someone created a variable that is a dictionary or something like that. So those aren't going to be super fun up front, but they are highly impactful, and I think probably a good place to get started. All of this, though, is a bit of a meta conversation that won't make much sense until you actually see a challenge. And with that in mind, let me stop sharing for 1 second. With that in mind, so far, does anyone have any questions about this direction, concerns about this direction, excitement about this direction, however you wanna go with it?
I am really excited about this direction. My question is, for each of these like categories, I'm assuming like variables, we should have a challenge called like variables, right?
Yeah.
But some of them, like circle, is like a class function or like a class exercise.
Yeah.
How are we going? Are these going to be in like subdirectories, or is it just going to be like, for 101, you should go through this list of challenges?
Yeah. So I gave some thought to this, and my honest answer to this is so in the README is a table, like a markdown table. And that table right now only contains 1 or 2 like challenges in some of the categories, just because that's what we have that like meets this new criteria. Each challenge should be its own subfolder, and each subfolder should contain 3 things: a stub file, which, if you've never heard that term before, is just a file with almost nothing in it, like maybe a very specifically named Python function and then pass, right? So a stub file, a README, and the README should explain the challenge and also provide links to documentation under a hints section, just to like, you don't want to necessarily give away the answer, but you do want to make sure that people like can struggle for a while and then can go find a really good resource to learn more. And then the third thing that it has is a test file. That test file needs to use unit test and not PyTest. I know that makes all of us a little unhappy, but again, the goal is that no one has to pip install anything. And so that limits us to just stuff in the standard library. And honestly, unit test is pretty great across the board, having used other languages. So yeah, in terms of naming, naming is the second hardest problem in computer science. So I'm not going to put a lot of restrictions on it. I am going to say, and you might notice this, Brandon, I am going to say that the naming structure should be camel-cased and all lowercase for folders and file names. And that is just to make headaches go away when it comes to like different operating systems and things like that. But outside of that, like if you want to create a challenge called variables, that's great. If you want to name that something more fun, or it's like a specific project that encompasses variables and other things, then that's also great. In terms of order, I would say the order that exists in the project right now, like of cards, is how it should be laid out in the table. But your choices essentially will be, you can go exercise by exercise through the table, or you can jump around, whichever makes most sense to you. Does that answer your question effectively?
Yeah, okay, that makes sense.
Cool. And by the way, Heather, thank you for dropping the link. I appreciate that. Definitely
Yeah,
space
so
that.
the one thing that I would say is, I mean, I'm excited and also slightly intimidated. So the things that I'm excited about are, you know, I'll be able to accomplish my goal of saying, okay, here's a topic that I don't know about. Let me learn that, and then learn it well enough that I can create a challenge. Or these are almost like toy projects, right?
Yeah.
And also it reinforces some good developer practice that I have gotten kind of lazy about, and that's doing tests and also doing a good README. And I know from talking to a couple of engineering managers who represent companies that don't do the whiteboarding thing, but they were very clear that the thing that they look for is they want to look at your GitHub. They want to see that you've got a really good README on the GitHub, like, why are you doing this project? Express what's going on there, and that you have tests in your code and that your code is clean. So, I think in terms of becoming a better developer in general, being able to do these things with some discipline around, just development. But it is slightly intimidating. I think that's going to get better once I see like the models that you're going to do, like the templates or whatever.
Yeah.
And so that's kind of how that's, I'm thrilled and terrified.
Yeah, no, that is one completely valid. This is a lot, and I've been writing Python for near half a decade, a little over half a decade. So there's just stuff that I know that I have forgotten people don't know, like both about Python 2 and Python 3. I think the intimidation factor will go away as we have more challenges that people can look at to get an idea of what they're doing. I also want to very explicitly say, I see this as a mentorship opportunity. So if you want to create challenges and have no idea where to start, I am happy, and hopefully others would be as well once they get the hang of things. Like, I am happy to hop on a Zoom call and have a conversation about what that process looks like, especially in the early days. One of the things I said last night to Brandon and Josh and Doc is, like, I understand that right now at the early stages of this model, it's going to rely pretty heavily on me as like a break point, and I dislike that. And want to like see that change, but the only way I know how to change that is to like jump in pretty actively and help people like feel comfortable. The other thing I want to specifically call out is this structure, and especially the like 500 series standard library stuff. This structure is designed so that if you don't know about something, I want you to decide, I'm doing this challenge, and open a PR to force you to learn it. In the industry or in places I've worked previously, I won't know if I'll say the industry as a whole, there's this thing called talk-based development, which is where you sign up to give a talk on a topic at like a conference, even though you know nothing about that thing. And then that forces you to learn that thing so that you can give the talk in 6 months, because now there's a deadline and an audience and you've got to figure it out. by all means, please use this repo as that. I know I, for one, am not going to let you fail. I'm gonna work with you. We're gonna have conversations in a PR. We're gonna have conversations in Discord and make sure that when you submit a challenge, it's what you want it to be and also meets our needs, and also teaches you something, both submitting and completing challenges, and also like it is an actually really great way to learn. Like I asked everyone a question last night and I said, okay, cool. If we want to teach people how to use unit test, how do you unit test? I'm going to be honest. I have absolutely no idea how to answer that question right now, but there is at least one whiteboard in my house that has 4 or 5 notes on how I'm going to try to do it later, and we'll see what happens. That's the kind of terrifying is a totally understandable way to approach this, but that's the kind of environment I want to enable, where you can just try stuff, throw stuff at the wall, open a PR early. This is just us, and we'll make sure that whatever you're trying to build gets into the repo and is good, because every contribution helps us, and every contribution, I firmly believe, can be made good, even if it doesn't start there. So yeah, I just want to specifically speak to imposter syndrome and being terrified, and like, especially if you're not familiar with contributing to open source projects, we have all been there. I like, if you're in this room right now, you can contribute to this repository because you know enough about Python to create a variable, which means there's stuff you can do. Please hop in. I want you to. Yeah, I'll stop rambling. Does anyone have any other questions?
I do.
Yeah.
My name is Mandy. I came into this meeting kind of, I don't want to say blind, but I'm assuming that these code challenges are going to be used for Lambda School. Is that correct?
So we are an independent Python user group made up of Lambda students.
Okay.
So they will not be used for Lambda School. This is an independent project.
So
however,
okay.
Yeah, go ahead.
So it's going to be used for people that are within this group.
Yeah.
Okay, and these are going to be, I mean, similar to, I'm assuming, kind of like code signal. I guess I'm not understanding the exact difference between something like this versus, doing problems on HackerRank.
Yeah, so that's one of those things that is easier to see than explain. So I will absolutely pull one up here in a second and share my screen, and we can work through one. And I think it will make a little more sense at that point.
Yeah, so I just wanted to add to that. The user group is actually exists under the umbrella of the Python Software Foundation, and our membership is made up of Lambda students, alumni, and staff. So we have a number of alumni that are members. We will continue to exist and be refreshed with new members as Lambda students enter into the data science track or get into CS and want to know more about Python. So that's kind of the membership flow at this time.
Yeah. Okay. Anybody else have any questions, or would it be helpful at this point for me to just open VS Code and let her rip?
Yeah, let's see what you got.
Okay. So notes before I do this. Unmute yourself and say things. This part's going to be interactive. I don't know if you've ever seen like Twitch does SQL or something, but I'm going to try my hardest not to write any code unless you guys suggest it. Unless y'all suggest it, trying to wipe that out of my language. And yeah, we'll go from there. So let me share this desktop. I'm just going to max out VS Code. And then the one that I think is easiest to start with is Circle. So we'll start there because I think most of you have enough Python knowledge to know this one. So this is what a challenge looks like in the README. You have a like general problem explanation, and also like hints that point to things like here's the formula on computing the area of a circle, because I'm not assuming that anyone has like done math in 12 years, because that's the last time I did math. Information about classes and instances in Python, stir and repr, if you've never heard of those, Python's math module, if you have no idea what that is. So basically, you can read this challenge, try really hard and not know what you're doing, and read all of this and still be able to get through things. The final thing is kind of pro forma, but it's an explanation of how to run tests just to make sure that each individual challenge has that. I should also mention, if you would like to follow along in a more involved way, you are welcome to either keep track in the repository on GitHub or to clone the repo. Let me go back here in my terminal just to make sure I'm in the right place. Outside of the README, which I'm going to have there, you also have the stub file. So this literally just has the class circle and nothing else. And then the test file, which has all of the tests that you need. And each test is also documented to attach it to a specific challenge, right? So let's start by reading the preview. So this says, create a class that represents a circle. The circle should have a radius, a diameter, and an area. It should also have a nice string representation. And so this is how you would instantiate that class. This is what the repr would be. This is how you would access radius, how you would access diameter, and how you would access area. And if no radius is provided, then the radius defaults to 1, and the diameter is still automatically set. So with that in mind, I'm just going to show you real quick to be good at TDD. I'm going to run the test file. Right. That should not be okay. Where am I right now? Oh, I'm not in the right folder. I was like, all tests should not pass. What is that? Great. So everything is erroring out. If I maximize this terminal, you can see that everything is erroring because there's no data in the class whatsoever. And we're going to work line by line and fix that. Oh, I've got to move this video thing. Cool. So we have let me move this README to the side since my screen is large enough. Is it going to let me? Come on now. There we go.
I have a question too regarding tests. I actually I purchased Algo Expert, which was not cheap.
Mm-hmm. Yeah.
And I thought it was really good, except for when you run the tests in the environment for one of their problems, which is actually not a difficult problem, all the tests would pass. But when you actually run it in Visual Studio Code, and then you see the output, it doesn't reproduce the correct thing. And so my beef with testing a lot of times is you don't always know if it's testing exactly what it should be testing.
Yeah. That is an inherent problem of testing. Absolutely. There are many, many answers I can give to that question. So first and foremost, some of it also depends on exactly what how complex the thing you're testing is, like both its dependency structure and also what you're doing. Since we're working in a folder with no additional packages and we are testing one particular thing, like one function or one class, that gives us a little bit more ability. So like right now, if you wanted to test it, you could clone this repo and run the same test file. And I know for a fact these tests will fail. I also know for a fact that they'll test the right thing, right? So some of this also comes back to, you want your challenge to be simple enough that you know you can test it, and also that other people can understand the tests. There are some exceptions to that, and I will show you. I'll show you an example if and when we finish this one of a challenge that exists right now that's a little more complex. But ultimately, if it relies only on the standard library and it's testing very specific things, then you should be able to, I say should with so many asterisks, but you should be able to ensure that the testing environment actually is reproducible. Where you get into trouble is when you have to start doing integration tests, or when, like, the moment you start mocking things is when you really have problems. is what I'll say. Like, I consider mocking to be a code smell. Like, if you're doing that, you really need to think seriously about why you need to do that. Anyways, I can't speak directly to the testing environment that you were working with. I'd have to look at it to know for sure. But I can tell you that I have at least one computer running Mac, Windows, and Linux, and have tested these challenges across all of them. And also I'm trying to currently figure out a way that we can use GitHub Actions to make sure that when you submit a challenge, we know that the testing environment works on every OS. So does that speak to your question a little bit?
Yeah, I think also just like, I think sometimes when we get into these coding challenges and you're doing it, and I think I like the fact that we're doing it in a Visual Studio Code, but you'll be in an artificial environment. And so it'll pass the test, but it's not actually producing the right output. So you're not actually seeing any output. And so you think, oh, it works. And so like having an actual output that you're seeing in the terminal as well, that where you can have that validation that, yeah, this is actually doing what I wanted it to do, I think is important as well.
Yeah, absolutely. And I should note, there are two ways to run the test to guarantee that output. So if you run Python-m unit test, which if you are unfamiliar, -m is a module flag for Python, and it essentially says execute a module directly. And then unit test, if you just run unit test by itself, will do auto test discovery. So it will try to find other unit test files. In this case, it found test_circle. And so that'll run that, but you could also run the test file directly. So you could run test circle, and the output right now will look the same, but if you run it when tests are passing, you will still get verbose output, because if you run the file directly, verbosity is set to 2, which is a keyword argument that just sets how detailed it is even when you succeed, not just when you fail. So I've tried to do as much as I can to make sure that, like, if you're someone who really, really likes seeing all of the environment and making sure that everything does what it's supposed to do, that's absolutely available to you.
I was also thinking, like, you know, sometimes with our tests, like, we just miss something, right? There's like a way to hack the code and like pass all the tests. And, you know I've done that unintentionally on tests. Like when I first started learning programming, like I just hack my way through a lot of challenges and stuff. But I think us as both contributors and like users, we should just make issues and make pull requests to like add tests when we find something that's like broken.
There is I'm working on issue templates right now, but there will be issue templates for your solution is wrong, and also your tests are wrong, and also you're teaching this wrong. So all of those issues are welcome. You know, no one is perfect. Testing is hard. Humans are very, very, very bad at complex granular logic, and this entire job is complex granular logic. So please, by all means, correct everyone. Anyways, okay, so we have this circle class. We need it to have a radius, a diameter, and an area, and we need that radius to default to 1 if no radius is passed. Does anyone want to unmute themselves and tell me what I should write?
Definite.
Definite. Okay, so we'll do def under init. What does init need to take?
Self.
Anything else?
Radius
equals 1.
Yeah.
Okay, equals 1. All right. Anything else in what's in the init function? What's the body?
Self.radius equals radius.
Okay. Perfect. Okay. Anything else? What do I need to add?
You can put in a def string.
Okay. Def under str.
You want a rep or two? Is that when you, because in the README, it didn't really specify if you're expecting, like,
okay.
it was like nice string representation. So like, what does that mean?
Very good question. I purposefully was unclear there. Let's look at here. So this says circle should have both a string representation and a repr representation equal to circle radius. So both the dunder str and the dunder repr are going to be identical. So my question for you then is, do we have to implement both?
I would say yes.
Maybe not. Just if you just have like a repr, will it use that for your string? I don't know.
I don't think so. I think you have to have them explicitly defined.
I've never like experimented with that.
which do we want to try first?
I say explicitly. I don't know. I'm always for like writing out a little bit more to make it more readable.
Okay. What
maybe the repr first?
All right, we have two sides on this. I need people who haven't spoken yet to tell me which one they think we should go. I need a tiebreaker.
We already have string written. Let's go with string.
Go. Okay. How do you want me to write the string?
I don't know. Do you want to use an F string? So like,
F.
Yeah, return.
Circle.
Yeah, circle with the radius of.
With self.radius.
Yeah.
Inside with the curly braces.
Okay.
Yeah.
Self.radius. Okay. So since we did dunder str, do we want to just go with dunder str? Or do we want to also try dunder repr simultaneously with it?
Well, without a repr, I think the test will fail. But I guess we could try running the test just to see what happens.
Let's do this without test for 1 second, just because I think it will be interesting. Let me make this take up a little more of the screen. And then I'm in a virtual environment right now. So I'm going to pip install IPython just because I think it will be easier for the purposes of this discussion.
I'm sorry, this is just a quick question because I want to keep up with y'all. Should I fork the repo and then clone it, or just clone it?
I would say fork the repository.
Okay.
Yeah. So you can do this in the plain Python REPL, but I like the way that IPython provides like syntax highlighting and a little bit better like output. So let's just say from circle import circle, and then let's create a circle. So C equals circle, and let's say 5. Okay, and then if we do print C, you get circle 5. If we do repr C, okay, so repr doesn't do the thing. So let's implement repr, and let's copy this down. Whoa, that did not work. Why? Is it? There we go. Okay, let's change this to be repr. And hit save. So if we run the test now, we'll do Python. Let's just do this, test circle. And then we can scroll up, see if we got anything. Okay, cool. We've got an error for diameter. We have, if no radius is provided, that should default to 1. That's okay. We passed that test. We've got a whole lot of errors here. However, circle should take a radius as an argument. That radius is great. And then circle should have both a string and repr. That test also passes. So well done. Now, the one thing I do want to point out here, just to make sure that since we took one path, by default, a Python objects representation for both dunder str, or essentially the resolution order when you call print, is it looks for dunder str. If it doesn't find dunder str, it looks for dunder repr.
Okay.
Yeah. So dunder repr, if your dunder str and dunder repr are the same, then you only have to implement dunder repr. And in the Python community, less boilerplate is considered to be better, so you don't end up with a class that has a ton. Having said that, there is no wrong answer here. Both of the answers you guys gave are absolutely correct.
Yeah, if the tests are written differently, it might be nice to have the string contain additional information about
exactly
like the diameter, radius, or besides radius. Yeah.
Yeah. And one of the hints I have here goes into this, but I will just give you a general question here. Do you know the difference, or like the purposeful difference, between dunder repr and dunder str?
Well, the repr is supposed to be how you can construct it, like kind of like instructions, like what you
Yes.
for it.
Most people do not actually know that. I really appreciate that. So dunder repr, is anyone familiar with the pickle module? Is that a thing that anyone knows about? We don't use it very often anymore. Okay, so pickling is a way of saving your code representations to a file so that you can then open that file later and reinstantiate your program with like its current state, right? Dunder repr, when implemented, is meant for pickling. So it's meant so that your dunder repr, your representation, should always be the information necessary to recreate that exact class. Whereas your dunder str is whatever you probably want to print to the screen, right? So anyways, great, we got those pass. We need to, let me back up here. So now we have to talk about diameter and area. So we need to be able to access diameter and area the same way that we access radius, so just by dot notation. However, let's go down here. When the radius of your class changes, diameter and area should both automatically update. So if we start with a radius of 2 and we change the radius to 1, our diameter and our area should, let me fix that. Our diameter and our area should automatically update, but they aren't methods. How do we do this? Feel free to Google or tell me to look at a hint, either way. And I'm going to scroll down here so people can see all of those.
I mean, getters and setters, right?
Okay. There are very particular opinions on getters and setters in Python. How would you like to implement those getters and setters?
Let me think about this.
Yeah.
Because we could just have diameter and area as properties of our circle class, and then when we set radius, because that's the only thing we can set here, right? We don't want to like change diameter and then it would change also radius.
Later on, we do want to change diameter and also change radius. So here. However, we can't change area, right? So that will raise an attribute error.
Oh, okay, cool.
We just haven't gotten there yet, but you're asking good questions.
So is this where you would use a property instead of a method?
This is absolutely where you would use a property. Is everyone familiar with properties as like part of Python's classes? More or less?
I am, but I'm not sure why you would use a property here.
In order to have a calculated value rather than an attribute, where like if we did self dot diameter there we go, equals like radius times 2. So if we did this would work when we instantiate the class. But if we go to update radius later, there are a couple of ways that you could do it, but you essentially would have to do a lot more complex logic and a lot less Pythonic code, depending on who you are and how you're writing it.
So I'm sorry. I guess we need to come up with the diameter, and then we also need to come up with the area. Those are the two things.
Yep.
Okay. So those are the two things we need to produce. Okay.
So tell me what to write. I think we've had a little bit of discussion. Someone speak up.
All right. I think I have an idea. couldn't you just go, like, you just create a method, right? So
Okay.
like if we want to get area, we have the radius, right? So we could just, well, I don't know if we want to get the diameter first. I'm kind of jumping the gun here. We would probably need to get the diameter, which is just the radius times 2, right?
So what
Okay.
should I?
So
what should
you should
I?
just write def,
Yeah.
and then get underscore diameter, and then self.
Here's the problem with that. When we get the diameter, we're supposed to just be able to do like class dot diameter. There's no parentheses where we're calling a method.
Yeah. Why couldn't you? So you just say diameter, get def diameter. Is that what you're saying?
So are you saying there's a difference between properties and what we have here in our init?
Yes, there's
a distinction. Okay, so I don't think I've ever gone down that road with the distinction between the two.
Okay, so this is great. Okay, so let me go down here, and we'll click making an auto updating attribute, which this is a thing we can look at. So I forgot that was a video. I'm not going to make you watch that. I'm just going to do a little bit of a lesson here. Okay, so in Python, these inside of your init function, those are attributes. They are not properties. Those are different, okay? Properties can be created in a couple of ways, in an advanced way using something called descriptors, but in a more general way using the property decorator, which is like this. So what we can do then is say def diameter, which takes self and returns self.radius times 2. Okay. Now, what property does, what the decorator does, is it lets you access diameter as though it was an attribute, and it just runs this function without you having to call it, right? So if we were to import this, we can say from circle import circle, circle, and then C equals, we'll just do a default one like that. And then if I do C.radius, I get that. And if I do C.diameter, there we go, right? If I get rid of this property decorator, like that, let me quit and do IPython once more. We'll just do that, and I do C.radius, that will work. But if I do C.diameter, well, that's a bound method. So I have to actually call that if I want to do anything, right? So the property decorator actually gives us kind of like an invisible attribute, which in Python is called a property.
So what is the benefit of doing that way? Because I would definitely, like, intuitively, I would have done just like def and then diameter.
Yeah.
Automatically updating, I think, is the key, right?
Yeah, automatically updating.
That's awesome. Yeah.
So right now, if you change radius, you don't have to do any complex logic to change diameter, because diameter is updated in real time. So let me show you what that looks like. If we do this like that, we can say C.radius and C.diameter. And if we update radius, let's do C.radius equals 5. And then do C.diameter. The diameter has automatically updated. We haven't had to do any complex logic at all. We haven't had to even tell Python that you should be watching radius to do whatever, because we now have a calculation that's happening in real time, but we still get to access it like it's an attribute. Now, the problem with this, because if you notice, we have to be able to update. We have to be able to update diameter as well. If I call C.diameter equals 2, like I want to bring the circle's radius back down to 1, I can't set the attribute. And this is where we start getting into Python's version of getters and setters, which is a little bit different. So let me quit this and just stop for a second. Is everyone with me? Does everyone understand what we just did?
So you can change it one way, but you can't like go back. Is that what you're saying?
Currently, based on this current implementation, we can actually, so like right now, we can change our class, we can update the diameter by changing the radius, but we can't update the radius by changing the diameter, right? So yeah, go ahead.
Okay, so because like c.diameter doesn't exist, right? We're not saving that anyway. Essentially, we just have a function that is like basically this is get diameter, and we have the logic in there. It doesn't actually store anything. It doesn't store the attribute.
Yeah. Right.
So when you want to be able to go back in the other direction, then we don't need to do a getter. We only need to do a setter here, right?
Right. Yeah. So technically speaking, property is what defines a getter.
Right.
In like a Pythonic way, right? In general, if you read the Python documentation, they actually go into this specifically. If you are ever defining get anything, you're doing it wrong. You should never ever define a get method and a set method. You should always be using the syntax that you're about to learn by like finishing this class, which is part of why this is here. So okay, so we can now get the diameter. Again, I'm going to recommend, to understand most of this, you watch this auto updating attribute setup here, but you can actually just Google, I believe, getters and setters Python, and we're going to ignore everything until we get to, oh man, everyone pushes the official docs way down there. Let's do the Stack Overflow one because I'm pretty sure they'll do it. Great. Okay, cool. This is a Python property. This person links to the documentation here. So here's properties. So this is where they say like, hey, don't do get X and set X and delete X. Instead, define a property like voltage. And then if you ever need to, or define a property like X. And if you ever need to set X, now that we have a property, you can call at that property name dot setter, and now we can redefine the behavior for setting diameter, for example. We can also define how diameter can be deleted or if it can be deleted, right? We can raise errors here if someone tries something. So with that, Brandon, I think you know where we're going. Do you want to walk us through what we should be writing here?
So we want to be able to change radius or diameter in our class, right?
Yep. Yeah.
So we could do setters for both diameter and radius.
Interesting. Why would you want to do a setter for radius?
Well, when we change the radius, we need to set the diameter.
But that's already happening.
Right. I guess though, if we can also set diameter though.
Okay, you are asking an extremely good question that we're going to run into like very quickly. So I'm going to ask you to divert that thought process and just walk me through how we can implement a setter in for diameter.
Sure. So it would be at diameter dot setter.
Mm-hmm. And then what's the method?
We're going to define diameter.
Okay, this is actually deeply important. I'm just going to hit pass for now. So we have a property diameter and a method named diameter. And so now we can access diameter like it's an attribute. If we're going to define a setter, we use the property name as the decorator and add dot setter. And then this sounds weird, but the method needs to be identically named, right? These are not foobar banana variables. These have to be named exactly the way that we're doing it. Okay? All right. How would you...
Do we need the
Yeah,
value? Do we need the value as an argument though? So it's going to have a different number of arguments, or how does that work?
Yeah, no, that I was going to let that fail. Good catch.
Okay.
So we'll say new diameter. Okay. How do you think we should implement this setter? What should it set?
Return new diameter?
Well, so diameter is a property, right? We don't have self.diameter, or we do, but we don't have it as an attribute of the class.
But can you just like, the new diameter is what you're calling the parameter though? So wouldn't you just return that?
No,
Well,
or
so
would you,
or is it more?
Would you go self dot new diameter would equal diameter? Would
so
that?
if we
Oh,
do that, diameter equals new diameter.
It wouldn't have the self though, right? Really?
Yeah, it wouldn't.
Well, and it wouldn't have new diameter twice. So yeah, never mind.
So this is a completely valid line of code. So I want to take a second. What do you think this does?
Sets the diameter whenever.
No,
Will we be updating the diameter?
no,
So
it
that
would
would
be
just make it
self dot new. It would be self dot new diameter equals diameter, wouldn't it?
Well, that way you're making a new attribute called new diameter.
There we go.
Which is, I don't think we need that, or is that like an intermediate step to what we need to do? I don't know.
It's not. No. So
okay.
Very good questions. What this is doing is creating a new attribute called self.newDiameter, but it isn't updating the radius, which means it won't actually update the diameter either, right? Because we have a property called diameter. So we need to update and diameter is derived from the radius. So what we actually need to update in this setter, self.radius.
Self.radius equals
divided by 2.
Yeah, diameter divided by 2. Yep.
Okay.
All right.
New diameter divided by 2. Okay, I see.
Yeah, because new diameter is the parameter that's coming in, right? You could also name that diameter, but there's this thing that happens mentally when you type a word so many times where you no longer understand what it means if it's spelled correctly or what exactly it's doing. So I like to make sure that if I'm dealing with a new value, I'm at least explicitly defining that. Okay, so now what this means is, or actually let's see if some more tests pass. We'll do Python test circle, and then I'll raise this up here. Okay, so now if no radius is provided, the radius should default to 1. That one is passing. The diameter of a circle should be the radius of the circle times 2. So we've got that. That's passing. We implemented that getter correctly. Diameter and area change based on radius. This is erroring out, but that's because we do not have an area currently. We'll get to that one next. The value error exception radius cannot be negative. That's just straight up failing. If you don't know how to read tests, by the way, the difference between an error and a failure is an error is something is just straight up implemented incorrectly, and a failure is you're doing something, but it's wrong.
It's wrong. So how do you make it, you would do like the absolute value, right? To make sure that it's not negative?
Well, let's save that one for last. We'll focus on area next.
Okay.
Yeah. So let me lower this here and clear my terminal. Okay. So now we have diameter and we have a diameter setter, right? So now let's talk about area, right? So the area, if you're unfamiliar with the formula for area, the area is pi times radius squared. Right? So we need to access area the same way that we access diameter, but you can't set the area. And if the radius or the diameter change, the area needs to update. How do you think we should go about this?
You should follow the same idea behind what we did for diameter. So we need to do the at property. And then you do a def, and then you do the area self. And then inside that you say return, and then that's where you set the initial equation. So self dot radius to the second or to the exponential power at times. And this is where you're going to have to import probably like math. So you can use the pi.
Yep. So now we can do, there we go. Okay, let's play with it first so you can see how this works now. I always like to mess around in a REPL a little bit. So we'll import, or sorry, from, yes, import circle C equals circle C dot radius C dot diameter C dot area. All right, let's update radius. C dot radius equals 2. That means C dot radius updated and C dot diameter, yeah, there we go. Updated and C dot area updated. If I change diameter again, so let's do C dot diameter equals, let's change this to 5 because that'll be interesting. And then we'll do C dot radius, C dot diameter, and C dot area. Let's try to set area. C dot area equals, let's do just 3.14.
That won't work.
Can't set attribute. Okay.
Yeah,
so
you got to do the same thing as what we did with diameter, which is the second part.
We actually don't, because we want that to fail exactly like we saw. We want to be able to set the radius, and we want to be able to set the diameter, but we do not want to be able to set the area. So
I see.
So great. So let's run some tests again. We'll do Python test circle. We got one failure, and that failure is everything else is passing. So congratulations. This is a functioning Pythonic circle class, right? We're not raising a value error if the radius can't be negative. So we need to make sure that if I try to initially set the radius to a negative value, like C equals circle -1, or if I ever try to update it to a negative value, that it always raises a value error. How do you think we do that?
You use the ABS, and then put it inside the whatchamacallits, not the curly braces, the smooth braces. So you would
like this?
Yeah.
Okay, so let me ask you a question. Will this raise a value error if I pass it a negative number, or will it just convert it to a positive integer?
It will just convert it.
Yeah, you never reach the error. Is the error part of the test that we do need that to happen?
Yeah, it will actually, it wants you to raise an error, right? It is checking that value error is raised specifically. What do we think?
Do we have to do a try catch inside Init?
I've
never done it with Init before.
It's okay. What would we be catching?
If it's a negative value passed in.
Like, I have to define a value error. Yeah, I haven't done a whole lot of that. I'd have to Google, I guess.
Yeah. Hey, Google, take a minute. I want.
So yeah, you would definitely want to do like a try, and then you would say like if the number equals and then like absolute and then that value, then, and if it doesn't raise value error, this is a negative number that you're passing in, kind of thing. Would that work?
I think yeah, like the backwards way of it, right? Like we're not trying to catch the error, we're trying to raise the error. So I think we could just do an if statement, and if radius is less than 0, raise our error.
Oh, well, that's stinking easy.
We're not out of the woods yet. Hold on.
No? Okay.
So let me ask you a question about Python objects in general. When does the init function run?
Initially.
Right? Yeah, that wasn't a trick question. That wasn't a trick question. That was
yeah,
right.
when you instantiate a new.
So this will throw the error correctly if I try to create a circle with a negative value. What happens if I try to update an existing circle to a negative value?
Nothing right now.
Right.
Yeah.
I can suddenly set it to a negative value. Okay.
You have to do it when you on the properties, right? So if you would do your if there, wouldn't you?
Well, I think
Right.
Yeah.
You can directly change the radius just by saying like your instance name dot radius equals whatever.
Mm-hmm.
So how do we circumvent that?
Yeah,
So
that's a good question.
I think we should make a setter for radius.
Like I can just make a setter for radius, you think?
I don't see why not.
Okay, let's give it a shot. We'll go under repr because I preferred under methods up front. And let's say at radius dot setter def radius self. What goes in the self block? Or wait, self. We'll say new radius.
Yeah, we need a new radius.
Oh, would it be that's where you would put your if statement? Yeah. And so that's where it would, if radius is less than 0, then you'd raise that error.
Yeah. I'm going to say less than or equal to 0 because 0 is also not valid, which it talks about there a little bit later. But we'll say raise value error radius cannot be negative. I'm going to capitalize radius so that the test is not fragile. You could change caps every character and it would work. It just requires that error message. So if radius is less than or equal to 0, then raise value error.
Here, you need an equal sign.
Oh, sorry. I have ligatures in my font. So this is less than, and this is less than or equal to.
Oh.
Yeah. I understand that that's confusing. Thank you for bringing that up. I like fancy fonts, so every now and then my code will look weird. Please call it out. Yeah. Okay. So if radius is less than, if new radius is less than or equal to 0, and then we can do self dot radius is equal to new radius. Okay. This isn't going to work. And I'll show you in 1 second. If we do Python test circle, we get this error. Name radius is not defined.
Because it's not a property, it's actually okay.
This is an attribute, yeah. Can something be bold, or how do you do that? Or is there another thing we have to add on there?
So something can be both. In general, you'll see one of two patterns in Python. So the first pattern is that you will have an attribute, like let's say self dot underscore radius is equal to radius. But the problem with this is no longer catching an error if I instantiate it with a negative number, right? So this works if you don't need to do any error catching on instantiation of a class, like when you initialize a class. And
so you just have to put the underscore under it, and that's it.
Yeah.
In
so
that
that is
case, yeah.
Okay. So that is conventionally in Python. This is a private variable. It is not private in any way. There is nothing protected about it. There are many ways to get around it. This is just meant to communicate to other developers. Hey, don't touch this directly. Use these properties that I've given you, right? But like I said, this won't work. We could still instantiate the class with negative. So, what do you think we can do? Just like throw guesses at the wall. Google whatever you need to as well.
I mean, in all of our other setters, oh shoot. Okay, hold on. No, give me a minute.
Yeah. I also just want to point out that learning this fact when I started learning object-oriented programming actually broke my brain for a solid hour. So this will be fun when we get there. Brandon, I've heard you almost get there a couple times, so I'm just going to ask you a question. Okay.
Okay.
Where does the @radius decorator get created?
With the property.
Right. So what do we definitely need here right now, at least just to make the setter work the way we want it to?
Oh, we need the @property setter or @property radius.
Okay. So let's. Sorry. Whoops. At property def radius self return self dot radius. Okay, so now we have a setter, right? So this is the part that broke my brain, and I'm just going to ask you the question real quick. If I were right now to have my init function be self.radius equals radius, what happens under the hood? Because from the object's perspective, radius is a property. Like self.radius is bound to a method.
Right. So it's going to call the setter.
It's going to call the setter. Yeah. So even though this looks like we're just setting an attribute, because we've defined a property and a setter, this here is actually calling this function.
So it calls it or just refer to it?
So self.radius refers to it. The equals sign specifically calls the setter.
Oh, we'll call it. Okay.
Right? And then radius becomes the new radius value. Right? Which means we now have no duplication in our code whatsoever. Everything can be accessed correctly. We are raising errors properly. And if we run our tests, ooh, what failed? Maximum recursion death. Oh, where are we recursing? Oh, sorry. Hold on a second.
Yeah.
That's what I meant to do. Okay. I knew I brought up the self._radius thing. Let me make sure that works. Yeah, okay. So we're making radius a property, which is this value here, right? Since this self.radius equals radius calls the radius setter, we can't at the end of this function call self.radius equals new radius because it creates an infinite recursive loop, right? Because self.radius calls the setter, which then calls self.radius, which calls the setter, which then calls self.radius, which calls the setter, right?
So that _radius is actually a different it's a private variable, and it's just defined as a private variable because it has that underscore, but it doesn't actually do anything in reality. It's just a convention.
Exactly. Yes.
Okay.
Yeah. All right. So check it out.
If we were terrible, set _radius.
What do you mean? Could we, if we were terrible?
Yeah. So like if we instantiate C as a new circle, and then C._radius equals whatever.
Yes. So this is a bonus I considered adding, and I didn't want to because almost no one in the Python community wants you to do this, even though I like it. But let's talk about this for a second. So first of all, congratulations. You guys did a challenge. You have a Pythonic class. You learned a little something about getters and setters. You learned a little something about properties and attributes. Seriously, well done. I hope you learned something, and I hope that was enjoyable. let's import circle real quick. So we'll say from circle import circle. And if we say C equals circle, and we'll do 1 even though it defaults to that. So we have C dot radius, C dot diameter, and C dot area. All of that's correct. We also have access, though, if we wanted to C dot radius, right? And we can, there's nothing preventing us from saying that, which breaks our entire thing, right? So there is kind of a way to get past this. I'm going to very explicitly say that if you Google private variables in Python, every Stack Overflow post, every blog post, every Medium post, and almost every Python developer is going to tell you there is no way to do that and you shouldn't try, just use a single underscore. Having said that, let's break the rules a little bit. So if you add a double underscore like this and hit save, and let's quit this real quick. And let's quit this real quick, and then let me do this. We'll import circle, we'll instantiate circle, and we'll do the general. Okay, so C dot underscore radius doesn't exist. Let's do C dot double underscore radius. Do you think this is going to exist?
Yeah, I think it exists. Oh.
Okay, so this is a Python feature called name mangling. So if I run dir C, which will show me all of the methods that exist on C, and we scroll up, Python has created an attribute that begins single underscore name of your class double underscore attribute, which means you can still access this, right? So if we do C underscore circle radius, then that works, right? And we have the same problem, okay? However, we've added a layer of abstraction that protects this. And the other thing that's necessary is this gets into like inheritance a little bit. But what this is designed for, if you ever actually want to use it, is it's designed for you to have an attribute that the person subclassing you can't alter, right? So do private variables exist in Python? No, asterisk. You can name mangle some things though, right? So again, it's you're kind of kicking the can down the road. If I wanted to, you know, set this to -1, I could, and then everything's broken again. But so like, it's not actually private. We can still fuck everyone's life up, right? But it adds one extra layer of unexpected behavior that at least kind of helps things make sense, right? Yeah, that's just by the way, I had to go deep into the depths of Python's both source code and documentation to find out that existed. Literally no one in Python ever wants you to do this. It is something that you do if you're like building the next NumPy, and not something that you do if you're actually writing code that other people are supposed to consume. And the reason for that, I'll stop sharing for a second. The reason for that is that Pythonically speaking, as a philosophy, Python believes in a Grace Hopper ideology of ask forgiveness, not permission. And what that means is you as a developer should not write code that catches every possible thing that breaks, should not should not try to prevent your users from doing things. This is not Java. Don't try to think for your user. Let your user blow their own code up if they want to. They'll learn a valuable lesson. That is the actual, the Python philosophy is the people using your code are adults. If they want to punch themselves in the face, they can. And that's how you should approach things, right? It's easy as programmers to be like really controlling and try to do all this stuff. But at the end of the day, that's not the Python way. The Python way is, I don't know, if they give you a string when you ask for a number, just let Python tell them that they messed up. right? Your application, like if you're dealing with user input in like a web application, you should do more error handling because those people are not developers. But the code you're writing is only going to be consumed by other developers. So why would you go through so much trouble to keep something private? Just like let someone break something and write good tests. There are definite cons to that. Having, like, I write a lot of Rust code as well. There are definitive cons to not having private variables. But generally speaking, it's a wash. It's kind of okay. We believe in duck typing and dynamic typing. Anyways, questions?
Okay,
Did everyone enjoy that?
Go ahead and stop the recording here, and then we can finish up.
Nick, would you mind sharing your screen?